here we discuss about indirect arc furnace. The electrode are projected through a chamber at each end along the horizontal axis. So come to the picture, 1 minute. See here, two electrodes are in horizontal axis and projected in a horizontal axis, and two electrodes are supplied by a voltage, okay, and connected with a voltage supply. And here in the furnace, charge particles is present. In between the two electrodes, arc is produced. See, this is the diagram. Here arc is produced. So, and charge is also heated. So charge is in the form of when it will heat, it is in the form of molten metal, okay. And charge here, another is that charging door is there, okay. And this is the electrode. Two electrodes are projected in a horizontal axis, and steel cell with a refractory lining. This is the steel cell with a refractory lining is there, and rocking unit is the here, okay. So indirect arc furnace, that means here charge is charge is present, but it is only the arc is formed in between the two electrodes. That is called as the indirect arc. So the electrode are projected through the chamber at each end along the horizontal axis. This furnace is also sometimes called rocking arc furnace. This furnace is sometimes called as a rocking arc furnace. The charge in the furnace is heated not only by radiation from the arc between the electrode tips, but also by convection from the heated refracted during the rocking action. So the efficiency of the such furnace is higher. The power input of the furnace is regulated by adjusting the arc length by moving the electrode. Even though it can be used in iron foundries where small quantities of iron are required frequently, the main application of this furnace is the melting of non-ferrous metal. This point is one of the important point is this furnace is melting of non-ferrous metal. Indirect arc is a it can be a MCQ question, multiple choice question in your any exam. So indirect arc furnace, what is the advantages and disadvantages and this application? So lower overall production cost per ton of a molten metal, sound casting in thin and intricate design can be produced, metal losses due to oxidation and voltization are quite low, flexible in operation. Disadvantages: no inherent steering action is there, no current flow through the charge, so there is a no steering action, okay. Continuous rocking should be done, distribute the heat uniformly. Application: the main application of this furnace is melting of non-ferrous metal. This is the main and important application, that this type of furnace is melting of non-ferrous metal. You use for this type of furnace for melting of non-ferrous metal. Clear? So next come to what is this induction heating. So induction heating is any new topic, that is the induction. So you know the induction, it is a rapid, clean, non-polluting heating from which can be used to heat a metal to change the conductivity material properties. The coil itself do not get hot. The heating effect is under control. The solid state transistor technology has made induction heating much easier, cost effective heating of application including soldering and induction blazing, induction heat treatment. So everybody know this is the induction. It is high frequency current is flowing through this is the and there is a induction coil, that is called a magnetron. Okay, magnetron coil. You can say it is a magnetron coil. It is just like a induction, our induction coil. See, heat object is present and you have to be heated. So induction heating is our, in case of electrical phenomenon, is different. Okay, so in case of electrical phenomenon, induction heating is based on the principle of transformer. We know that transformer having two windings, one is primary and other is secondary. Always primary we can give a supply AC source, and secondary is connected to the load. So there is a primary winding through which AC current is passed. The coil is magnetically coupled with a metal to be heated, which acts as a secondary. An electric current is induced in a metal when AC current is passes through the primary coil. That means in secondary it has some charged pieces. Okay, so when a current will flow through the primary, ultimately in secondary you will get some melting metal. Okay, like, because they are magnetically coupled. That's the point, there are magnetically coupled. So there are the following different types of induction furnace are: core type low frequency induction furnace, and all this coreless type high frequency induction furnace. So core type furnace, there are the operate similar to winding transformer. Okay, direct, vertical or indirect. Three types of core type furnace are there. There are low frequency induction furnace, we can say it. Okay, so we will discuss one by one. What is the direct core type? What is the vertical core type? What is indirect core type? So yeah, come to the direct type induction furnace. So see here, this is the direct core type. Here primary winding is there, secondary winding is open. So here in case of primary winding and secondary winding is magnetical coupled. Annular hearth. In primary winding you have an annular hearth, in secondary winding you have an annular hearth, and in case of annular hearth it contains some charge particles. Charge. So when a current flows through, the charge is heated in primary. Ultimately it is magnetically coupled and the charge is also heated and it forms a molten metal in secondary. That is the main point is here. When you give supply, here annular hearth is present, both side of the both side. So inside the annular hearth charge is present. So when you give supply, so current will flow and the charge is heated inside the annular hearth and it forms into a molten metal secondary side, because they are magnetically coupled. Okay, so in before it is open circuit in case of secondary side. When it is in the form of molten metal, it forms into a short circuit in secondary side. That is the theory. So back to the theory. Direct core type induction furnace. The core type furnace is essentially transformer in which charge is to be heated. Your point is you have to heat the charge. It is your main point. Form of singleton secondary circuit. It is a magnetically coupled of a primary by an iron core. It is a magnetic iron core is present. It is magnetically coupled with both primary and secondary. The furnace consists of a hearth, that is called the annular hearth, or you can say the hearth, in the form of throw, THROUGS throw, which contains the charge, to be melted in the form of annular ring. That means the charge is heated. When it is heated, it will melt into in the form of annular ring. This type of furnace has following characteristics. That means this type of furnace is also having some characteristics. This metal ring, quite larger diameter, is magnetically interlinked with primary winding, which is energized from an AC source. The magnetic coupling between the primary and secondary is very weak. It results high leakage reactance and low PF, low power factor. To overcome this increased reactance, furnace should be operated at a low frequency in order to enhance. Okay, we will discuss